Now, we now come to a very special system of equation that involves lines and circles. Here is the first example. We're going to solve for the coordinates. We're going to find a coordinate where a line intersects a circle. We're going to use the method of substitution. So we're going to plug in the expression for y from equation 2. This is equation 1, this is equation 2. We're going to plug in this expression for y into the y from equation 1. So let's do that. We have x squared plus y squared equals 25. So if we replace that with x plus 1 squared equals 25 and solve for x, we will find that x squared plus, if we do FOIL on this, we'll get x squared plus 2x plus 1 equals 25. Now we're going to solve this. Let's solve this. Combining like terms together, we have 2x squared plus 2x plus 1 equals 25, which if we move the 25 over, subtract 25 from both sides, you will get 2x squared plus 2x minus 24 equals 0. And then we can divide everything by 2. Every term by 2 will lead us to x squared plus x minus 12 equals 0. We can factor this as x plus 4 and x minus 3 equals 0, in which case x equals negative 4. Let's write that properly. X equals negative 4 or x equals 3 using the zero product property. The last step is to plug in these x values into one of the equations. So we're going to plug it into the easier one. So y equals x plus 1. We'll plug in the first case, x equals negative 4. Y equals negative 4 plus 1, which is negative 3. The coordinate will be when x is negative 4, y equals negative 3. Alright, that's y equals negative 3. We got the first coordinate. And then the second coordinate, y equals 3 plus 1, so which is 4. And so the second coordinate will be 3, 4. And if we so we find the two solutions which represent where the line actually intersects the circle. Here is the graph of the line and the circle. We see this is a line has a slope of 1 and y-intercept of 1. Y-intercept of 1, slope of 1, and then that's a line. And the circle has a radius of 5, because this is the general formula for circle. X squared plus y squared equals r squared. So our radius in this case is 5. So radius is 5. And if we draw that circle that centers at origin with the radius of 5, we'll get that blue graph. And we can see obviously that the line is intersecting the circle in two locations, which matches our this is 3, 4, and then negative 4, negative 3, which matches the algebra that we just did over here. Here is a second example. So we're going to use the same method of substitution. We're just going to substitute y equals negative 2 into the first one. So let's do that. Will be x squared plus negative 2 squared equals 4, and then x squared plus 4, because negative 2 times negative 2 is 4, equals 4. We can subtract 4 from both sides now. So that will leave us with x squared equals 0. And if we take the square root of both sides, square root of x squared equals square root of 0 with a plus or minus. But we know the square root of 0 is 0, and it has no negative or positive, so it's x equals 0. Now we found the value of x equals 0, and it's only one value. And we can just plug it into the first one. first equation that has x in it. So we're going to have 0 squared plus y squared equals 4. 0 squared is 0, so y squared equals 4. And then take square root of both sides, and plus minus square root of 4, y equals plus minus 2. There are two answers possible, y equals 2 or y equals negative 2. But we already know that y is negative 2, so we pick the one that says y equals negative 2. So our coordinate will be 0, negative 2. We already found x is 0, and we pick y equals negative 2 from this other equation. So the coordinate of intersection of the line and the circle is at 0, negative 2. Here is a graph. You can see that this is a circle with a radius of 2. So radius is 2. Radius is 2. And centers are the origin. And then this is a line y equals 2. It's a horizontal line. It actually intersects at one point. Alright. Compared to the first equation, the first problem, there's 2 points of intersection. Here is only 1 point of intersection. Now we're going to go to another example to see what kind of intersection we have in this. Here is the original problem. And now we're going to use substitution to solve this just like the other ones. So let's solve. So we have x squared plus x minus 8 squared equals 16. And then we use multiplication of x minus 8 squared. So we're going to multiply and get x squared minus 16x plus 64 equals 16. Now, if we combine terms together, like terms, 2x squared minus 16x, and then subtract 16 from both sides. 16 from both sides, we get plus 48. If we divide both sides now, of each side by 2, we'll get x squared minus 8x plus 32 equals 0. If I try to factor this, that is not going to be possible. So we are left with solving it by using either quadratic formula or by completing the square. Let's solve by completing the square and see what happens. So we have x squared minus 8x equals negative 32 if we subtract 32 from both sides. 32 from both sides. So we have x squared minus 8x equals negative 32. And now we're going to put a blank. X squared minus 8x plus blank equals negative 32 plus blank. So this blank is the number that will complete the square. A half of 8 is negative 8 is negative 4. Negative 4 squared is 16. So we're going to add 16 to both sides. And then we can factor the left side as x minus 4 squared. And the right side will be negative 16. Now we're going to take square root of both sides. So x minus 4 squared equals plus minus square root of negative 16. Now we know that the square root of a negative number is an imaginary number. So we're going to end up with x minus 4 equals plus minus 4i. And so x equals 4 plus minus 4i. This is an imaginary solution. Imaginary solution. That means the line and the circles are not intersecting. No intersection. No real number intersection. When there is no intersection, that means there's no solution. We can actually see it from this graph. There's a graph down here, the same equation. That this is a line, y equals x minus a, that's the red one. And the blue one is the circle. We can see that the circle and the line actually don't intersect because of the imaginary solution that we got using the algebra. So there you have it. Circle and line can intersect in three ways. Either one point of intersection, like 1 point of intersection, or 2 points of intersection, or no point of intersection. Those are the 3 possible ways in which a line can interact with a circle. I hope that this helps a little. Thanks for watching.